Hello guys, I am Parinita and welcome to my channel to polish your CSC concepts with me. So let's get started. In today's video we are going to learn about a very interesting topic of TOC, theory of computation, that is Turing machine. As you must know, in our previous videos we have already talked about all the other machines. We have talked about different types of grammars and we have talked about the corresponding machines which are used for those grammars. Like we have learnt about NFA, DFA, we have learned about linear bounded automata, push down automata, and so now in this video we are going to learn about Turing machine. So the basic difference, I hope you have already seen those videos. Now the main difference between the previous machines that we have seen and this machine, that is Turing machine, is this Turing machine contains infinite memory. This is one of the main characteristic of Turing machine, that it contains infinite amount of memory. And Turing machine is used for which type of languages? It is used for language 0, that is language of type 0, that is recursively enumerable language. For that we are using Turing machine. Now today we are going to see this with the help of an example that construct the Turing machine that accepts the language L equal to a raised to n, b raised to n, c raised to n, where n is greater than or equal to 1 over the alphabet set of alphabets given is a comma b. Now a raised to n, b raised to n, c raised to n, this is one of the most common example that we can solve using Turing machine. So I have taken that, and with the help of this example we will see how to construct the tape, how to construct the Turing machine, and how to see that which states are accepting, how to see the rejection states. We will see all the details about Turing machine in this video, right? Okay, so let's start the example. The language they have given is a raised to n, b raised to n, c raised to n, and the value of n can be greater than or equal to 1. So what can be my set of languages? What can I write about my set of languages? N can be greater than or equal to 1. So if I take n equal to 1 here, if I keep n equal to 1 here, what I will get? I will get a raised to 1, b raised to n, c raised to 1. So a raised to 1, b raised to 1, c raised to 1 will give me a, b, c. If I take n equal to 2, a square, b square, c square, that means a, b, b, c, c. If I take n equal to 3, I will get a, b, 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 c, c, c. Like that means the moral of the story is what I am getting. In this language, I should always get equal number of A's, B's and C's. Right? This is the main thing that we can conclude here. That the number of A, number of B and number of C's will always be equal in this language. Now for this language what we have to do is we have to make Turing machine. Now in order to construct Turing machine, first of all let's construct the tape. As we have discussed, in Turing machine we will be having one tape and then we will be having machine. So first of all, if I want to draw the tape, how the tape will be, what will be present in my tape? For example, 1, 2, there are n number of A's, then there are n number of B's, then there are n number of C's. Fine. Now as I told that we are having infinite memory. So in Turing machine what we are considering, that here in the left hand side I am having, like, my tape is sealed, means I am having limited memory, but in this in my right side, in the left hand side we will consider that the tape is sealed, but in the right side we can extend the tape as much as possible, as much as we want, right? So after n number of A's, after n number of B's and n number of C's, I can add blank spaces here, that all these are the blank spaces in the right side of the tape. Fine. So this is my tape that I have constructed as per the given language. Fine. Now the second thing that we have to construct is what? Turing machine. We have to construct Turing machine for this. Now how to construct? This is the tape that we have constructed. Now we will assume that my state Q0 is my initial state and my initial state will be pointing to this first position of tape, that is it will be pointing to this first A. So keeping this into consideration, let's start making Turing machine. So this will be my first state will be Q0. Now it is very simple. See, try to understand the notations, then it will be really simple. First of all, I am having Q0. Now from Q0, how we will construct the tape? We just have to take care. See, what is the main fact that we have to take care? That always in my language, the number of A's, B's and C's should be equal. If the number of A's, B's and C's are equal, then that should be accepted. Then such language should be accepted by my Turing machine. And if they are not equal, then in such cases, it should not be accepted. Fine. So what we will do, the concept that we will be using is, first of all, we will trace first A, then we will go and trace first B, and then we will go and trace first C. Then again we will go to second A, second B, second C, third A, third B, third C. At the end, we should be left only with the blank symbols, means the number of A's, B's, like this we will go on loop, right? We will cancel out the first A, cancel out the first B and cancel out the first C. Then second A, second B, second C, like that the loop goes on, and at the last, at the end of the loop, we should be left with only blank symbols. Means in the last loop also I should be getting one number of A, one number of B and one number of C. This means what? Whatever the number of loops are, that is equal to the number of A's and equal to the number of B's and equal to the number of C's. That means I can say that A raised to n, B raised to n, C raised to n is satisfied. That means number of A's, B's and C's are equal. Fine, I hope you are understanding. If not, see here also with the help of this machine we will go through it. So the only funda is we have to take care that number of A's, B's and C's must be equal. We will trace 1B, 1B, 1A, 1B, 1C. Again second A, second B, second C, like that. Fine. So first of all, Q0 is our initial state. In our initial state, we are pointing this first A. Now, how we are writing it, that whenever I am coming, whenever I am getting any A, whenever we are getting any A, we have to like cancel it out. For cancelling out, for example, let's say we will, when we are cancelling A, see, for example, we are taking here, when we are cancelling A, we will cancel it out with X. It is just a notation, right? For B, we will cancel it out with Y, and for C, we will cancel it out with Z. Fine. So these are the three symbols that we have taken. So whenever I am getting A, I will cancel it out, I will make it X and I will move right side. Understood? See, understand this notation carefully. This notation is very important, that whenever I will encounter in Q0, Q0 means this initial state when we are pointing here, right? Now, so what this much notation says, we will move to any next state, let's name it Q1. So what this notation says, that in Q0, whenever I am encountering A, I will make it X and I will move right. Encounter A, make it X, like cancel it out and make it X and then move right. Fine. So this notation means that. Then we will move to the next state. Now next state is, for example, Q1. Next state is Q1. Now in Q1, if I am again getting A, see, if I am again getting A, I will remain in the same state. There will be no change. So if I am getting A, for example, let's make the loop here. If I am again getting A, I don't want to do anything because in the first loop I have to cancel out only one A, right? So in the second A, if I am getting again A, I will keep A as it is and I will move right. Fine. Okay, then we will go to next state. Understood? If I am again getting A, I will not do anything. I will keep A as it is and then I will just move right. But if I am getting second B, see, after getting second A, when I am getting first A, I will cancel it out and I will make it X and move right. Now after getting first B in Q1 state, if I am getting first B, then again I have to cancel it out. I will make it what? I will make B as Y. So I will make it Y and I will move right. Fine. And I will move to new symbol, a new state. For example, my new state, let's name it Q2. Again, the very similar thing that we have done, that after B, if I am getting again B, then I will keep it as it is and I will move right. Fine. But again, if I am getting first C, means in the second the second option is, if I am getting first C, then obviously I have to convert it right. I have to cancel it out. I have to make it Z and I will move right. Fine. Then for example, I will move to new state Q0, Q1, Q2, now Q3. Now in Q3 what we will do? Q3 means we are here. Fine, Q3 means we have already got C and then we are reaching to Q3. Now after getting C, what we need to do is, after getting C, when we are getting C, that means what? We have already got 1A, we have already got 1B and we have already got 1C. Now after getting 1C, again I have to scan from the beginning for second A. After getting first A, first B, first C, I want to go for second A, second B and second C. So after getting first A, I want to again go and search for A, right? I want to again go and search for second A. So what we will do, that after reaching to this Q3, means after getting first C, I again want to search for A. So for searching for A, I have to go here, and after going here, I will first get C. I will first get this X, because we have already changed our first A into X. So I will get what? I will get X. So what I will do? I will keep X as it is and I will move right, because after moving right I will go to second A, right? So first of all I will get X, I will keep X as it is and I will go to right, so that after going to right I will encounter the second A. That is my intention. Fine, so here it will come. Now what are the other possibilities in this Q3? One possibility is I will go and search for second A. Now the other possibilities are, if I am going, see, the other possibilities are, I have to go one by one left, because after C, this is tape, right? In tape I have to go one by one. So in tape, see what we were doing here in this case, after A I was moving right, after B I was moving right, but after C, see here A raised to B, A raised to N, B raised to N and C raised to N. My given language is A raised to N, B raised to N, C raised to N. That means C is my last symbol, there is no other symbol after C. So once I am reaching C, I will no more go to the right, I have to go to left after that. That means I have to go left. Now whatever I am, whenever I am going left, see, after encountering this first C, if I am going left side, then what are the possibilities of getting at the left side? At the left side, I can get this B as it is, I can get this Y, I can get this A as it is, or I can get this X. So we will be having 4 possibilities after going left from C. So which are the 4 possibilities? I can either get B or Y or A or X, right? B, Y, A, X. Because all these 4 possibilities are there in the left side of this C. So all these 4 possibilities are there. B, Y. Okay, for X we have written here, that is the first symbol. Okay, Z. Again, if this is the case, this is the C, then I can get Z also. So here X will not come, because as X will come here, it is the first symbol. Z will come here, right? So what I will do, in case I am encountering any of these, I will not change them, right? I will not change them, they will be as it is. So we will simply make them remain as it is and we will move left. So B will be left B and we will move left. If Y is encountered, we will remain it as it is, we will keep it as it is and move left. For A, we will keep it as it is and move left. Z will be kept as it is and we will move left. So in Q3, all these possibilities are there. And if there is X, then we will keep X as it is and we will move right, so that we are encountered to this second A. Fine. So this is the Turing machine. This is the main Turing machine. Okay. This Turing machine is for what? Up to here, we are showing just the loop. Just the loop, that after every iteration what will happen, that we will go to search first A, first B, first C, then again loop, second A, second B, second C, again loop, third A, third B, third C. This is for loop, right? Now what will happen if, see, we are at Q0, we have reached to Q0. Now at Q0, if number of A's are done, then in that case what we can do, see how to show the, now I am showing you how to show the accepting state. If for example, see, for example, now see, this is the loop, right? You got it. Up to this, Turing machine is completed for what? For our loop. That in with the help of this, we are searching first A, first B, first C, then again loop, second A, second B, second C, again loop, third A, third B, third C, like that. Now, for example, you have converted all the A's into X. For example, you have converted all the A's into X, right? So what will happen, that there will come a time when after Q0, we will directly get, after X we will directly get Y. Understood? There will come a time that at Q0 we will directly get Y, because when it will happen, when you have converted all the A's into X. So in such case, I have to make a different state, that after Q0, it is possible that I am getting directly Y, this Y, because that means all the A's are completed. At that time, if I am getting directly Y, I can keep that Y as it is and I will move right. For example, let's name it as Q4. Right, in Q4 again, if I am getting Y, because if this is also converted, if this B is also converted, if all the B's are converted, and again if I am getting Y, then simply I will keep that Y as it is and I will move right. And apart from that, if I am getting Z, if I am getting directly Z, then I will keep Z also as it is, because Z is for what? After cancelling C. For example, this is also cancelled, this is also cancelled. And so if I am getting Z, I will keep the Z as it is and I will move right. I will simply go on moving right. So in this way, we will go on checking that how many number of A's, B's and C's are there. And at the end, if I am simply left with the blank symbol, that means all A's, all B's and all C's are traversed. So at that time, I will be left with only blank. I will, B is for blank, right? So I will keep the blank as it is and I will move right. And ultimately, I can say that this is my acceptance state. I can say that this is once I have explored all the A's, B's and C's and I have got the blank symbol at the end of the tape, I can say that now I am at the acceptance state. Fine. So this is the whole Turing machine that is constructed for A raised to n, B raised to n, C raised to n. Fine. Okay. Apart from that, quickly let me show you rejection states. Which are the states which can cause you rejection? Means this is the acceptance state, that in which case we will accept the string. Now, which are the cases in which we will reject? In which our Turing machine will reject? These are the cases in which, if such cases occur, our Turing machine will reject them. So those cases are, if with Q4 I am getting B, if with Q4 I am getting B. After Q4 getting B means what? That there are still number of B's available. See, let me write it here. These are the states. Okay, Turing machine is visible. Fine. See, these are the states which should not be there. If our language is correct, then these states should not be there. Okay, and after that blank should not be there. In all these cases, we will get rejected by the Turing machine. Fine. Which are the states? See, after Q4, if you are getting B, because after Q4, you should not get B or C as it is. Because when, see, understand this thing, that when you are reaching to Q4, we are reaching to Q4 only after Q0, we are reaching to Q4 only when all the A's are explored, right? Now, all the A's are explored means what? If there are no more A remaining, there should not be any more B and C remaining also. Got it? Because number of A's, B's and C's, because our language says that number of A's, B's and C's are equal. So, if all the A's are explored, then all the B's and C's must also be explored. But if we are seeing that at Q4 there are still any B's or still any C's are remaining, you can say that, okay, this is something that we don't want. That means our number of A's and B's are not equal, and that means we will reject it and this language is not valid. Fine. So this is the reason. Now similarly, if at Q1, see Q1 is where, this is Q1, where the number of A's are still remaining. When you are going to Q1, when number of A's are still remaining. Now if number of A's are still remaining, then number of B's should also remain. You understood? If number of A's are remaining, then number of B's should also remain. But skipping the B, if you are directly getting Z, Z means what? Z is for C. So if number of A's are remaining, but number of B's are not remaining, that means again it is unequal. So after Q1, if you are directly getting Z, then it is rejected. Similarly, these two will be Q2. Similarly, after Q2, when you are reaching to Q2, see when you are reaching to Q2, when you still have B remaining, right? So, if you still, okay, this will be Q1. That after Q1, when you are at Q1, when the number of A's are remaining. So, if the number of A's are remaining, then B and C should also remain. So, if you are getting directly Z or C, that means it will be rejected. Similarly, when you are reaching to Q2, see this is Q2. Similarly, when you are reaching to Q2, you are reaching to Q2 only when you still have B remaining. Got it? This is B. So, when you still have B remaining, you are going to Q2. That means what? If the number of B's are remaining, then number of C should be remaining too. So, now in spite of C, if you are directly getting the blank space, that means again B is remaining but C is not remaining. That means again you can say that the number of B's and C's are unequal in that case. If directly after Q2 you are getting the blank space, then again it is not valid because it shows that number of A's, B's and C's are not equal. So these are the states that will cause our Turing machine to reject the string, and apart from that, this is our whole Turing machine that will accept the given language, that is A raised to n, B raised to n and C raised to n. I hope you have understood it. Let me know in the comment section if you still have any doubt, or if you like it, then also let me know, and please share it with your friends too. Thank you so much.